Okay. App color. Tree gen. Okay. Let's see. I believe the last thing I was dealing with was bugginess in yes. Okay, so what does each of these do? Let me remind myself. So there's my skeleton. There's the ghost skeleton. There's the thickness, and there's regrow the tree. Okay. So clearly it's not working because we get silver lines overlapping, which shouldn't happen, and we get brown lines that get drawn, like this one up top, that should just be silver, right? Like that one there, it shouldn't be considered colliding with anything. So what I want to find is a simplest possible test case that exposes a problem. And look at it from there. Where is... okay, I need longer... No, I need... That's base size, that's... I don't think they're ever going to collide. Interestingly, with that many branches, I don't think they ever collide. Like, look at that. Oh man, that's kind of weird. Okay, so add another layer, shrink them down as small as they get. Shrink that down, grow. Let me separate them. I'm trying to find something that is somewhat simple for me to visualize in my head what's going wrong with it. Okay, like that's correct though. No one in there. Where's my rotation? One of these rotates you. That's correct. That's correct. Yeah, I'm not finding any bugs at this layer, or at this level of branches. Boop. Alright, let me shrink this down again. Okay, so there's no problems. There are no problems there. Ooh, there we go. Problems. Problems where there should not be problems have arisen. Okay. So for example, those guys, they're all brown. Why are they brown? So last time I just took a while and stared at this, and I've been trying to figure out how I want to go about debugging this. And basically the problem is I don't know if that is an issue of it's colliding with one of its base or somebody else, and the check is just not working to prevent that, or if it thinks it's colliding with someone. I don't even know if that line is actually the line that's being tested, or if it's testing some other crazy line, or if it's testing against the right set of lines. So what I want to do is I started this thing for breaking down the process, right? And I want to continue down that route and continue to break the process down and make it so that I can stop and slide the process around in different ways so that I can pinpoint exact points where things go wrong and add more visualizations and stuff. Visualizations is how I make it go. Yeah, okay. So what I'm thinking of is, first of all, this method I did for extending the branches kind of works, but I'd like to improve it. So there was gen tree, there it is. Tree skeleton gen, sure. No. Fiery Drake says I should draw the Calliope in a different color as well. That's not a bad idea. So whenever one branch is trying to go down and it collides with another branch that prevents it from going down, it takes the other branch that prevented it and makes it blue. That would be pretty good. That would be pretty good for sure. What I could do is say that I'm going to generate the whole thing. Like, that makes me think I just want a thing where I can paint branches different colors, which I don't actually have right now. But that would just be a matter of saying at each point. Yeah, I like that idea a lot. That opens up an interesting possibility. So this is the branch point, and I believe it's an array of branch points that we're filling out. And wait, well, no, I need the thing with children. This must be it, right? Where is my? So from showing yes. Okay, tree skeleton vert is the right type. Okay, so this right here, I'm going to add to it, at least temporarily, like paint. Right? So it'll have this idea that it's been painted in a certain color, and when I first create them, I want them all to be painted silver. I'm going to take my colors here, and I'm going to move them up here. And yeah, I never did untabify that. I'm going to wait until 4coder has tabification to do that. So there's my colors. I'm going to add persist back for sky blue, which is a color you achieve by doing one part, well, a little less than a part of green, a part of blue, and a full alpha. Okay. And now, whenever I'm creating a point, where is that? Segments collide. Sure, it's not really where this needs to be. Whatever. Tree skeleton gen. Somewhere in here I start. Okay, there's a vertex. I start filling out its info. Its theta, its width. And let's see, where else do I use vert? So I'm setting its children there. Alright, so right up here when I first get it, I'm going to paint it silver. And then after that, it could be painted blue if, let's see, no collisions. So no collisions is up here somewhere. The new position, here's all the vertices we have so far. And if the new thing we're trying to place in CD collide, where does D come from? D comes from vertices child id.position. Well, what I'm going to do real quick is say that I want tree skeleton vert other vert to be vertices plus child ID. And I want this range here to be other vert position. Now, where else do vertices come up? They don't come up anywhere in here, so that's good. So if that causes a collision, then go ahead and say that other vert paint becomes sky blue. And then what I can do is when I'm tree skeleton gen, when I'm drawing these tree, where is that? MyGL skeleton. We won't have a color anymore. Instead, what'll happen is at each line we do, before we put down those vertices, we'll look at the child vert, get its paint. Alright, and then the other thing is I want the ghost tree to continue being brown. So for that to happen, basically if allow colliding is false or not, we'll determine this. So if I allow colliding, then I want this to paint silver. Else I want it to paint what was it? Faded gold. Alright, let's see if that's building. Line 261. Sliver. .404. Yes, you do not take a color. And you. Whoops. You do not take a color. That's odd. That's very weird. Well, first of all, I think I got my faded brown and my not faded brown backwards somehow. If I allow colliding, paint it silver. Okay, that's right. So allow colliding doesn't mean if I check for colliding, it means if I allow colliding to happen among the branches. So the one that allows colliding is the faded gold one. Okay. So that blue one there is causing somebody to stop, but it's causing all of them to stop? That seems odd. And then, like, a lot of them are not even coloring anybody blue. It's very weird. In fact, something else is broken because brown shouldn't have any gaps, and it does. Brown has lots of gaps all of a sudden. Not the same gaps as silver, but still gaps. Theta equals BP theta. You grab the new branch point. Read position does not in fact creates a branch point. Actual branch count. So that actually creates the vertex. Right here is the line where we actually create the vertex. But I assume all of them come through the for loop. Right? I mean, I shouldn't be getting any black ones here. I could just assert that and prove that I am, but I want to figure out why I am, because I'm assuming that's what's happening. Skeleton branch point right here, with K being the index in the vertices array. It gets written into the position, so it gets written into the queue, it has to pass through this point. Actual branch count. Alright, let me just confirm my theory that I think we're getting some of them not painted by saying up here, if I can find it, first of all, my GL skeleton again. Alright, if what's going on? Right, if the time comes to put down... Did I do this wrong? No, it's just going across to everybody and saying, if you look at your... if you have a child, what is that? Stack point, look at each one, look at its children. And then put that child on the top of the stack. And then you increment next child. That works? That seems like it shouldn't work. Oh, up here I'm saying if the next child is at 3, then we're done. Otherwise, if we're not there, try to get the next child, and if it exists, if it doesn't exist, we're done. If it does, look at the vertices, grab the child, use its paint, and put it down. Then put the child as a member of the stack to be drawn. So that's where I want to test if child vert paint dot r equals 0 and g equals 0 and b equals 0, then x equals 1, allow local x, let me launch a debugger here, because I'd like to break if that happens and see where it happened. App color. Okay, let's see if it happens. It does happen. Yes, somebody's paint is not being set. Just kind of confusing. Who is it? Pray tell. Child. The first one. That seems weird. Vertices. So 0 doesn't have black, it has that, which I believe is silver, which is what I want to see. But let me look at the one that comes after that. Oh. Interesting. So, as I said at the very beginning, there's something a little bit sloppy about how I did this for loop thing business last time that I'd kind of like to remedy now. So, what I did was I said that there's an I limit, and basically only do a step of the loop if we haven't reached that limit yet. But that isn't quite right, because this whole loop doesn't generate one branch. What happens in the body of this loop is not only do we look at a branch, but we also down here we generate it. And really what I want to do is limit the generation of new branches, because this is where we push things onto the queue. So I think it would be better to just make that correct. So limit is the number I want to stop at of branches. So basically I'll have some counter I that's global to the whole program, or to the whole loop, the whole execution of this function. And then every time this happens, I will say, alright, do this if you're allowed to. So that is, I is less than the limit, and you're allowed to for other reasons. Then do this, and increment I. Okay. Let's see if that is a little better. That should do them one at a time instead of in branches, groups, and I think it should allow for the branches to actually get painted, since they get painted on the outer loop, and I'm only limiting actually adding the branches. Tree Gen 253. That's even better. That's what I was looking for it to do. Well, it doesn't look good, obviously, but it's a much better effect of filling in branches. So you can see it's this one right here, I believe, that's causing it to break. And the fact that it's scale dependent is kind of annoying too. Like, the fact that those aren't blue is weird. Like, that should be causing these to become blue, right? So why is it not? I'll bet it's because they get repainted silver later. So let's say only do this initial painting here if we have a black paint still. So if my paint is still black, then get a new paint. That's better. That's much better. Okay, so blue ones are there, but they're blocking out brown ones. And in this case, that's perfectly accurate. Now, the fact that all three of them are blue is a little bit odd. I guess it's possible, though. Like, the one that's farthest to the left here blocks out this one first. then the middle one blocks out this one first, and then the farthest right one isn't blocked out until that one. It's possible. Interesting. Now, you can see that it's not always right. That brown one there should be causing this one here to be blue. Alright. So anyway, let's get to... there we go. Okay, so we have a situation. This blue is not actually colliding with this brown, so it for some reason is deciding that those two guys collide. Now, what I could do is really quickly grab our state, grab the state of our parameters, and save it so that we can reuse that state, since it's a pretty perfect one for detecting a bug. Okay, so ta-da! Alright, that I want to save. And since I can't save it, I will write it down. You know, an editor debugger that worked together well, what you would be able to do is say, take this thing that I'm looking at, and generate the code for inline initializing to this value. And just throw it into a function somewhere, and I'll plug it into my code myself. You don't even have to put it in the right spot. Just generate the code that has the right data plugged into the members, and then I can use that. So there you go, free feature idea. If you're making an IDE with a debugger, there's a feature you want. Now, let me write that down. The base doesn't change. Levels is 4. Initial step is 182. Step decay is 0.51999981. Initial thickness is 10. Thickness decay, I don't think those actually matter to this problem. Those have to do with generating the polygon around the skeleton, but I'm just writing them down. And d theta is 72. Okay. Boom. Let's go generate this thing that the computer had 90% of the power it needed to generate for me, and chose not to, just to annoy me. Tree parameters. Well, here's how I prefer to do it. I'll if0 this out for now. And we'll have an else area where I can grab a copy of this. And then plug everything in. So the base is whatever it was, levels of 4, initial step 182, Step decay is 0.51999981. Initial thickness is 10. Yeah, so those are totally out of order, which is great. 72. Let's pop you up there so that you're in order. Thickness decay. Yep. 72, 10, 180. Alright. Looks good. And that should then mean that we can just recreate that over and over again until it's fixed, right? Yes, perfect. So we have it. We captured that exact moment, and now we're going to figure out why it thinks those two things are colliding. So my next question is, this guy who's painted blue, can I pause right at the moment when we're about to do that? Since we have exactly one blue thing, I should be able to just pause then, and I'll know that it's the one time that a blue and a brown happen. And I'll be able to see if the points are in the right spots, because I suspect that we have a bug where the points aren't lined up where they should be when I do the segment testing, although it could be a problem with the segment tester itself. We could have to go back to that again, and this will help to figure that out. Looking for no collisions. Oh man. No collisions. Right there. That's where we paint it blue. I want to see it when it happens. Okay. Actually, I don't want to see it yet, though. I want to see it when it first happens. I want to... Boom. Okay. Yeah, I don't care about that one. Boom. Okay, so it thinks that these two segments collide. Or that... No. And it thinks that it's not exempt. Okay. It's right that that segment would not be exempt from the segment that it's colliding with, so the exemption maybe isn't failing. But let's look at the 4 points that we have here. Base and new position make a line, and C and D make a line. Again, I'd love to be able to just inline the text that generates those, but instead I'll write them down. So here's base. 518.934.814, because there's no way I'm going to sit here and figure out how to visualize this. 418.568.939. New position. Five, 4, 3.273.010. 410.661.041. Alright. C is at 536.812.561. 363.547.363. D is at 536.812.622. That's very close to C. I have to go back and see if that makes sense. It might be a nearly vertical line. That might be true. That might be the truth. The blue one is the CD, by the way. Just so you're following along with me. The blue one is the nearly vertical one, which is C to D. 9, 6. Okay. So we've captured that. Let me see if those points now make sense to what I'm seeing up there. So the blue one has a C right here, and that's 536.812561. And its D is basically the same spot. They're basically on the same exact X point. Now the Y point ranges from 363 to 337. Yeah, so the points look like they could be right, because this brown one here, the base is 518 and the end is 543, which straddles that and it goes in the right direction, and the Y goes from 418 up to 410. There's no reason those should be colliding, and yet they are. So that suggests to me that the segment collision isn't all the way there yet after all. So I'm going to turn on the segment collision UI again. We're going to see if that hypothesis is correct. Now the only thing I'm going to do is to avoid, well actually there's a couple things I'm going to do. Not the only thing. A couple of things. First of all, it's always annoyed me that I didn't ever properly finish this. So the Y has to be reinitialized to this at the beginning. Boom. That way it'll line up correctly. And the other thing is I'm going to plug in our 4 points right here. So the first line is the brown line, and it's ranging from 518.9348114F to 418.568.939.F. It's not an extra point there. Alright. And then there's 543.27301OF and 410.661041. Okay. There's the blue one now is 536.812561, comma 363.547363. Okay. And then this next one is 536.812622. Make sure I put in the F's so it knows they're floating point singles. 0.956696F. Okay. So now we can test those two segments. Whoops. Segments collide. Needs to take this. We're going to call that P out equals 0. We get down to here. And I believe the rule was that CL is the point that I care about. So if P out, I've come to the conclusion that right now I'm not trying to make the optimized algorithm. I'm trying to just do as many things as possible to get information out, so later on, once I know what I'm doing, I can optimize it. But for now, it's totally fine if I have a sloppy version that doesn't know whether or not it's outputting a collision point all the time, and if I'm getting extra data, like I'm painting my vertices for debugging and whatnot, it's all part of the process of figuring out how I want to generate the tree. Everyone out of the way. Yeah, it thinks those two things are colliding, which is kind of weird. if I take this point, it's a very specific moment where it decides that those can collide. That appears to be one of them. There should be one right here, though, right? Why is there a missing brown spot, by the way? Why is there not a brown one right there? Is my... Huh. It's a bit weird. I'll have to deal with that, too. Alright, so let's take a look at that. Clearly it shouldn't think that those collide, but it does. So, BPAF, no, there's no L systems, really. I mean, you could make an abstract argument. There's nothing in here that is thinking about L systems. I didn't do any L systems to create it. You could make the argument that it sort of does what an L system does and that it does replacements and stuff, but really what you do when you generate trees with L systems is you do the language, you do the well, not the language, the L system, you apply the L system for a little while and then you use that to generate your tree, and I'm just generating a tree directly. And debugging some of the primitives right now before I do the fancy stuff that I'm planning to do. Alright, right here. We have a false collision. So let's figure out why we have a false collision. How much time am I at? Alright, this will be the last thing I do. If I can solve this false collision, that'll be it for today. And if I can't, within a certain amount of time, that will also be it for today. But preferably I can. Put my notebook down. Okay. So I have my points. Let me just write them down real quick. Make sure I'll double check that they are where I think they are. Okay. BPAF asks what this is for. I'm just doing this right now to test my editor 4coder, which is the project I work on most of the time. So I had to come up with a project to test it in, to put the editor to use. And so I am using my editor 4coder to make a tree because it's something I don't know too well. It's something I don't have too much experience with, so it would test me actually writing code in the wild, you know. Okay. So we get the rows of our matrix, row 1, row 2. And let's see, x is not 0, so that doesn't happen. R2.x also not 0, so this happens. And then boom, we have R2. Great. And then it's weird how that's already so close to simplifying into something that's going to kill out y. Isn't that interesting? So R2 y is not 0, so that won't happen. R1 y is not 0, so this will happen. And then we compute the point. And the thing is, the point is correct, right? If you're looking at that thing, the point that it was putting the point in the right spot, it just shouldn't have been coloring them white. And now neither of those are 0. So we have solved for ourselves a good looking system. I then multiply these out so that we get 1s there, and now our z's contain the position. Okay, so that position is correct. It looks right. Now the problem is just that it comes to the conclusion, erroneously, that these two guys overlap at some point when it shouldn't. So basically result equals 1, yes, and 1 means they do collide. And so it should get caught on one of these that they don't, and it doesn't. So we're going to figure out which one. A1 and A2 are not equal. So this happens, right? So that is A1 and A2 span this way. They're not, their x's position. It goes, the brown one is not vertical, is basically what that means. And then we get the range from A1 to A2. And I believe that just is there to make sure that the smaller one is to the left. Yes. Yes, okay. And then CL 536. Let me put this up on the board. We can take out R1, R2, CL. Okay, so 536, the x position is squarely between A1 and A2. So this should not pass, right? That point is squarely between those. So then it doesn't bother to test this part, which would do the same thing for y. But it does come down here and say, does B1 equal B2? And the answer should be no, it does not. But it's very close. So it might be a problem there with the fact that that's very close to being equal, that it confuses the issue. And it says, okay, is the point... Okay, so 536, 812622, it's testing whether the point is in the x range. So it's already determined that the point is in the x range of the A points. But then when it comes down here, it thinks that the B line, because it's so close to being vertical, but not quite, it thinks it's horizontal. And then it looks at interesting. It looks at the point and determines that it is not outside of the range, right? It's basically like, oh, it's not less than start, it's not more than the end. And the start is b1.x 53681261262, right? So it determines that x is actually exactly equal to end, and so it thinks, aha. But the problem is it shouldn't have been using the horizontal width test at all. That's just wrong. It doesn't matter whether or not we do inclusive range, because I was starting to think maybe I need to figure out inclusive range and exclusive range. No, that's not it. The problem is we don't want to allow this to have any... We need to add a little bit of epsilon to these tests, I think. It's a bit sloppy. But I'm not sure what other choice I have, since I don't really know what I am doing with these. I could try, when I do an official version, switching to fixed point and getting better control, therefore, over the positioning of these numbers. But I'm going to say we need to add an epsilon on line 193 and on line 180. And it looks, by the looks of things, like an epsilon of 0.001 would be enough. Actually, I could go as far as 0.0001. Okay. Let's try that. So we'll call it epsilon 0.0001f, and then I want a negative epsilon. Nah. Yeah. I don't know. Negative epsilon. And then what I want is some real 32 x diff which will go xdiff equals a1.x minus a2.x. And if xdiff is less than negative epsilon and xdiff is greater than epsilon. Okay. So that's never a good sign when you have to do that. So I should maybe think about how I want to better represent points. Like I said, fixed point maybe would fix it. I don't know. I'm not really any good at this stuff. Aha! Well, it knows that those aren't colliding, and it doesn't look like it thinks they are anywhere in this range. So let me go back to not using that. Okay, so we can see the tree for what it is. There it is. Okay. Now I want that on, and let's see if I move it around, I don't get any jitteriness anymore, so that's cool. Let's turn that off. That looks way better. That looks pretty solid now. Let's add more branches. Watch it grow. It's interesting. So remember, all the blue ones are ones that have blocked other ones from growing. Now if I add in brown, the thickness, now we have some seriously cool looking stuff going on. Oh, that's so cool. Wow. That's pretty cool. Obviously has some issues. Since the width thing isn't that great yet. Where it doesn't know that the widthy part, like it's not colliding with the segment, but it doesn't know that once it adds in the width it will be colliding. So that's gonna happen. Not until I do something smarter there. Huh. But it is really neat. If I decrease the width enough, it doesn't really look like a problem because you never see it happen. But it looks kind of funny if I have it decaying too slowly. That is pretty cool. I like that a lot. Alright, I think that's it for me today. Thanks everyone who came out at some point. Let's see, I don't know, viewer count's still pretty good, so I'll let everyone know that I'm planning to do... I have some school off next week, at the beginning of next week. So I'm planning to do a few weekend streams, some bonus streams. I might work on the tree or 4coder experiments or something, not sure yet. But Yeah, so look forward to a couple bonus streams. I have a quick question. Is it dark in here? Do I look kind of like Abner Incognito-ish? I didn't even think of that because I don't normally go this late. Anyway, yeah, thanks for coming. Uh, See you guys later.